domestic wiring system, and consumption and cost of electrical energy. In this topic, we will discuss the following subtopics: sources of mains electricity, power transmission, domestic wiring system, and consumption and cost of electrical energy. Introduction. There are several sources of mains electricity in Kenya, with the two main ones being hydroelectricity and geothermal. After generation at the power station, electrical energy is delivered to consumers through cables. This is the Ngong power station. Wind is used to turn the valves which produce kinetic energy that is converted into electrical energy by the generators.
Is the generation of
At Olkaria Power Station, steam from the ground turns the turbines, which then rotate the coils of the generators. Click on the play button to make
Now the turbine is now converting the energy in steam into mechanical energy, and then from there, it is converts electrical energy in the generator. This turbine is running at 3,000 revolutions per minute, spinning. Actually, the shaft, you can see my thing is stationary, that's rotating at 3,000 RPM, revolution per minute. And also turning the generator on the other side. The generator produces electricity at 11,000 volts, but the power is 35 megawatts. So that is what comes out on this unit alone. So we have unit 1, 35 megawatts, unit 2, 35 megawatts, and unit 3, 35 megawatts.
In a hydroelectric power station, potential energy of the water stored in the high dam is used to rotate turbines in the generators. Click on the play button to make your observations. In nuclear power stations, radioactive matter breaks under nuclear fission, releasing a lot of energy which heats up the water into steam. This steam under high pressure is used to rotate the turbines. Click on the play button to make your observations.
Nuclear energy facilities generate carbon-free electricity in 30 countries around the world. Nuclear energy production is similar to the ways fossil-fueled power plants generate electricity. A nuclear energy facility provides clean, safe electricity 24 hours a day. Let's go inside the plant to find out how. In most generating plants, whether coal, nuclear, or natural gas, some form of energy is used to heat water into steam. This steam turns a turbine that is coupled to an electromagnet called a generator. The generator produces electricity. While the model is the same, there is a key difference between nuclear energy facilities and other electricity generating plants. Power plants that run on fossil fuels burn coal, oil or natural gas to generate the heat that creates steam. In a nuclear energy facility, a chain reaction of splitting atoms releases heat. This reaction takes place in the reactor. All reactors are designed, built, and operated with safety as a top priority.
Tidal generator makes use of tidal waves, up and down motion as the source of kinetic energy. Click on the play button to make your observations.
The water of the oceans of the world is almost always in motion. Hardly ever interrupted, waves break at the coastlines, sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Hoyt Hydro WaveGen is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases.
Solar panels have photocells which converts light energy into electrical energy. Batteries are used to store the energy for use. In diesel-powered generators, a diesel engine rotates the coil or the magnet of the generator. For a coal-powered generator, the water is heated into steam and a high pressure using coal. The animation below shows cables carrying electrical power at high voltage. Click on the play button to make your observations. Explanation. At the generating power station, the voltage produced is stepped up to between 220 and 500 kilovolts for transmission along the grid system and stepped down to a voltage of between 11 and 33 kilovolts at the consumer substation. This voltage is further stepped down to between 415 and 240 volts for domestic use. Dangers of high voltage transmission. In high voltage transmission, a strong electric field is set up between the electric cables and the earth. This may ionize the air around the cables, especially during rainy seasons or when the air is humid. This may cause a danger of electrocution to people or other animals nearby. This danger is usually minimized by supporting the cables high above the ground by pylons. If the cables are to pass through towns and cities, the cables are usually buried underground. The animation below shows cables carrying high voltage current. Click on its play button to observe. The domestic wiring system. This is the connection of electric circuits in a building for low voltage consumption. In such a system, there are two main circuits, namely the lighting circuit for lights and the ring main circuit for the sockets. Typically, the voltage is supplied at 240 volts at a frequency of 50 Hz to the consumer unit. From there, it is split into the ring main circuit and the lighting circuit. This illustration shows a complete domestic wiring system. Observation 1. When the 5A fuse is fixed and a switch to a bulb is switched on, the bulb lights. Observation 2. The 30A fuse for the cooker, when switched on, makes the light-emitting diode to go on, showing that the cooker circuit is complete. Observation 3. The 30A fuse for the sockets completes the ring main circuit, causing the iron box to emit radiations, showing the presence of current. Electrical energy consumption and cost. In Form 3, we learned that power is the rate of doing work measured in watts, where 1 watt is equal to 1 joule per second. Alternatively, energy was seen as a product of power and time, implying that 1 joule equals to 1 watt multiplied by 1 second. In electrical power consumption, a watt-second is too small a unit for practical purposes, and a kilowatt-hour is normally preferred as 1 unit of electrical energy. 1 kilowatt-hour is therefore the amount of electrical energy consumed in 1 hour at a power rating of 1 kilowatt. This is equivalent to 1000 watts multiplied by 3600 seconds, which equals to 3,600,000 joules. Electricity meter. An electricity meter records the total number of units consumed on the premises where it is located in a given period of time. The cost of electricity consumed during such a time period is calculated as per the units consumed. This cost is equal to the number of kilowatt hours multiplied by the cost per unit.